Hello and welcome to Chapter 2. In this chapter, we will take a look at two of the most common effects created with particles: debris and trails. So before we begin, let me show you where our war scene currently stands. If you remember, we already demolished the building with the RBD sim, and we have a very nice explosion here destroying this first column. So what I want to do now is not only create particle trails that will eventually generate the volumes, but also some additional detail to convey small-scale debris. This kind of secondary destruction is easier to create with particles rather than with RBDs, and it's also faster to simulate. So since now the scene is quite heavy and it may be very time-consuming to use the actual geometry, and also, if you haven't seen Volume 2, I will start with a very simple geometry to teach you the core concepts, and then we can apply them to our final scene. So let's begin. I have prepared a very simple scene with a geometry resembling a column and two cameras, something similar to what we have in our war scene. So camera number 1 is a little bit closer than camera number 2, which is looking upward onto the column. Within the column geometry, I only have this box that is 4 meters high and 60 centimeters wide and deep. It has also been placed with its base on the ground. So let's start by fracturing this geometry. So I will quickly create a sphere, and I will roughly place it in the middle of the column, roughly at 2.75 meters, or actually let's try 2.5 meters. Convert it into a volume with an ISO offset node, and then scatter some points. So the default of 1000 is too much. Let's try with 80 points. Now let's drop an RBD material fracture node. Connect the column to the first input and the points to the fourth input. Now within the RBD material fracture node, I will delete this fracture level 2. And in fracture level 1, I will make sure to change the scatter points to 0, because we're going to use the incoming points to create the fracture. So click here on input points. Let's now create a very simple RBD simulation with the RBD bullet solver. So connect the output of the RBD material fracture to the first input of the RBD bullet solver. Now select the RBD bullet solver node, go to the ground tab, and activate the ground plane. So this should be all necessary to make the column crumble down. So you can press play just to see if it's working. You may also want to turn on the real-time toggle. And for now, this is mimicking the result we had with the exploding column. Of course, right now the motion is not so explosive, but we will add some collisions later. Just for you to know, what I'm planning to do is when the pieces of the column detach, I will start emitting particles, both to create the trails and the small secondary debris. But consider that we will only want the debris to emit from the inner faces at the precise moment that the column starts breaking. So before we can go further, let's quickly set up the collisions and the active fragments of the column. So let's create another sphere. Let's now template the column. Make sure that the new sphere is a polygon sphere. You can increase the resolution a bit. And I'll make it smaller. Let's say 0.5, 0.5, and 0.5. And the uniform scale, I'll bring it down to 0.75. Also, I will add a transform node. And move the sphere backwards towards the negative z coordinate. So let's bring it up a bit. Let's say 2 meters and to minus 3 meters in z. Now let's try connecting the sphere to the fourth input of the RBD bullet solver. And let's create a very simple animation where the sphere moves quickly and crashes into the column. So you can press Alt and click on the translate property to create a keyframe. Then move forward in time, say 8 frames. And then move forward your sphere to create a new keyframe. So probably I'll bring it upward a bit. And maybe to the right. If a keyframe hasn't been created automatically, you can again Alt-click the translate, or you could also change the keyframe button to auto. And one final thing I'm going to do is move the sphere out of the way. So I'll move to frame 10 and bring the sphere back a bit, just so the falling pieces don't collide with the sphere. So let's do a quick test to see how this looks. Go back to frame 1 and press play. So notice how although the sphere is animated, here in the simulation it's acting as a static geometry. So let's go back to the RBD bullet solver. Let's find the collisions tab, and under initial object type, choose create the forming static objects. So let's see now. Okay, so now the sphere is working as expected. Of course, right now the collision is too strong. And another thing that we will need is some constraints. So let's first of all take care of the constraints. That's pretty simple. Just connect your second output of the RBD material fracture to the second input of the RBD bullet solver, and under the RBD material fracture node, find the constraint tabs, and by default they will be on. I will just bring down the primary strength to 10. This way the column will hold together the first few frames and then break with the impact. So let me just see what's happening. It appears to be breaking beforehand. Let's try increasing the strength. And let's try again. So it works for now. I still need to add some inactive pieces, but it's a good start for now. So to set up the active fragments, we can add an RBD configure node. Connect it right after your RBD material fracture node. And scroll down until you find the bullet data active property. So turn on this property, then turn on use bounds, and again scroll up. Here under the bounding type, select bounding box. So what I'm going to do is bring this box upward until we encompass only the fragments that we want to break apart. In this case, I will leave the upper and the lower fragments as inactive. I will then go back to my RBD solver, look through the camera, and press play.